My name is Denis, Magda, and this is the last workshop about multi-region deployments with YugabyteDB. A little bit about myself. I've been working with distributed databases and high-performance computing systems for the last 8 years. Presently, as you can guess, I'm with Yugabyte. I'm the head of developer relations team. And before Yugabyte, I was daily contributing to Apache Ignite. That's another distributed database. But that database is designed for high performance and memory computing. Prior to the databases and all of those distributed systems, I was in a little bit different sector of the engineering. I worked on the Java development team. I was developing JVM and JDK. So like if you are a Java developer, I know like the Java from inside. So, you know, if just we will right now, before we start talking about types and before we start talking about the types of multi-region deployments in YugabyteDB, we need to understand when those deployments are used. Basically, we need to talk about geo-distributed applications because those applications use YugabyteDB, deploy YugabyteDB in the multi-region way. So let's define geo-distributed apps. If this term is familiar to you, you can always actually go into Google and search for this term. You will come across several pages. One of them will be from Yugabyte. Another one would be from Microsoft Azure team. And basically, if to mix those two definitions, you'll find that geo-distributed apps are the applications that span multiple geographic locations. What you see on this map, we have multiple application instances of the same application, of the same microservice, and those applications works across several continents. But then you can ask a reasonable question, but what if I am developing an application that is for my local market, for my country, right, for my region, for my territory? Does it mean that this workshop is for me? Yes, it does, because under the geo-distributed app, a geo-distributed app is also an application that runs across several availability zones within a single region, like what we have on the map here. We have an application, 3 instances of the same application running across several availability zones in the US West region. Also, a geo-distributed application is an application that runs across multiple regions, but in close proximity. Because the first slide showed you how multiple application instances are deployed across several continents, right? But also, you can have a geo-distributed app that works across the United States in several regions, so that works across several European countries, right? And this might sound fancy, right? Kind of, yeah, like geo-distributed applications, nice term. But why would I bother building those types of applications? And I do believe that many of you who are on this online right now, you do understand why do you build geo-distributed apps and why you use YugabyteDB for those types of applications. But to make sure that everyone is on the same page, let's figure out why the one would design a geo-distributed application. And we will do this in the engineering way. Imagine that you and I, we co-founded a company. We came up with some interesting company. We decided to create a fintech service. And the service basically allows you to observe the state of the stocks market, buy different stocks, sell equities, etc., etc. Sounds like we are reinventing the wheel, but we might have some secret sauce in place. Anyway, we came up with that fintech service and we deployed the very first instance of that service in the United States, in the US Central Zone, somewhere in that area. Because we are a startup company, we have to run fast, otherwise we will run out of money pretty soon. And on the first day of when the service was launched, we've got the first user. And this is Mrs. Blue. Mrs. Blue is a financial advisor from New York City. She lives there, and she read about our application in the news, and she started using our application. Wonderful. And also, hundreds of other users joined Mrs. Blue from all over the United States, and they also started experiencing what our service does. And then, several months later, a bad thing happened. There was a natural disaster in that location in the US Central, and then the whole data region went down. And we had our application running in that region. As long as the region was down, our application was down as well, right? Unfortunately. But as a startup company, we can afford different mistakes because we are at the early growth. We can afford this, but we have to take the lessons, right? And we, after this incident, we sit down and we decide, okay, let's do the research. And then we found that in fact, cloud outages happen all the time. Yes, every cloud environment comes with abundant resources. You can have virtual machines in all of the locations, you have fast networks, you have various services for streaming, messaging, etc., and blah, blah, blah. But also the cloud is very comprehensive and complex infrastructure and solution. And when you have a lot of dependencies, it can inevitably lead to outages. And if just to take AWS alone as an example, starting in 2011, AWS alone had a major outage at least once a year. And a major outage means that there were troubles in an entire region, such as the United States West or United States East. And on average, it took like 4 hours to recover an outage from an outage, which means that your application was unavailable during all of the time. And this is just, for the major outages. We do not even count zone level outages that take place, like I think, all the times. And here is, we are not blaming AWS. In fact, Amazon does a great job by putting together this page and meticulously updating it, because this is a memo for all of us who design and build applications that cloud also fails, and this is our responsibility as of application developers and architects to be ready for those outages, right? So thank Amazon for that. All right. The question then, what can I do about that, right? If cloud fails and that if my application can be impacted sooner or later, so what are my steps? What are my actions? Action number 1, just accept the fact that a cloud outage can impact your application. It's inevitable. It might happen. It might happen today. It might happen tomorrow. It might happen in a year or 5 years. And then once you accept this fact, start designing applications in a way that then run at least across multiple availability zones, or better, across multiple regions, right? And here is also when we are, usually when I discuss the high availability for applications, then this question comes up all the times. How about hybrid cloud deployments? If, Denis, you tell me that cloud fail, region can fail, zone can fail, should I deploy across multiple cloud environments? And actually, I just usually show the opinion and statement by Lydia Leon, which is one of the fascinating technology analysts, that said that before you even fantasize about multi-cloud for high availability, you should be multi-AZ in multiple regions. So generally, hybrid cloud deployments exist for different reasons, right? But if you don't actually, if you're deciding to deploy across multiple cloud just for the high availability, doesn't make sense. Your cloud provider already comes with multiple regions. So like if you want to withstand outages at the region level, just deploy across multiple regions using regions of your cloud provider, right? So, all right, you and I, as the co-founders of that fintech service, we learned the lesson, we did the research, we understood that outage that we experienced this month can happen and repeat a little bit later, and we took this lesson and deployed right now. Our application, our trading platform works across multiple regions in the United States. And then, let's say half year later, another disaster hits the continent, and the US West experiences different, instabilities. But our application is up and running, and because the traffic, Mrs. Blue's request and the request of all of the customers is redirected to another nodes in a different region. All right, so that was the first reason, high availability, and I think that one is the clear one. Anything else, you might ask? Is there any other reason when you would create geo-distributed applications and deploy YugabyteDB across multiple regions? Yes. Now, let's say that we need to call for help from different users. Please welcome new users who joined our application. And those users, they're not from the United States. Welcome, Mr. Green. This is a scientist from Berlin. And we also have Mr. Red, a musician from Mumbai. And right now, let's see like what those users will tell about their application usage experience. If we ask Mrs. Blue, and Mrs. Blue, all of them use our application through a mobile phone. Mrs. Blue just takes her mobile phone, opens our application, and goes to their trading platform, sees the market state, buys equities, sells equities, and sees different statistics. And she can say, wow, this application is lightning fast. It's really cool. Why does this happen? Because she lives near the location where we deploy our application instances and the database. And these 5 milliseconds, where did I take this 5 milliseconds latency? If you take Google Cloud Platform as an example, in Google Platform, 5 milliseconds is the latency time that you experience if the requests are within the same region. So this is what you get. But now let's say that we've got the new user, Mr. Green, who lives in Berlin, and if he is asked about the experience, he can say, yeah, the app is nice, I use the app, but sometimes the app is not responsive. I'm just opening this, I'm refreshing the screen, and like it takes several, let's say, seconds to refresh, let's say, the state of the market, and it's not a big deal, but it's not responsive. And if you ask Mr. Red can say, it's like, can we use something else? Why this application is always hanging? Why is it slow? And the difference here, because for Mr. Red, his request from the mobile applications needs to travel through the land under the ocean before they get to the database, to the application instances. So here is, we as creators of this fintech service, we need to achieve this experience. We want all of the users who live in different parts of the world, we want all of them to say that our application is lightning fast. This is the level of experience we want to achieve with our application. And this is what you can achieve with geo-distributed applications and multi-region deployments. All right, cool. We talked about high availability. We talked about performance. And finally, is that it? Not yet, my friend. Also, we cannot disregard data regulatory requirements because they are a big deal in many places. So what we have right now, you remember that we deployed this multi-region cluster and we deploy multiple instances of the same applications in the United States. And we've got the first users in Europe and Asia, in India. So you know that in Europe, we have GDPR, General Data Protection Regulations law that was put in place. And generally speaking, if we store personal information of Mr. Green, and we do store this because Mr. Green buys stuff through our application, then we are violating this regulation. Probably that's not a big deal right now, and the government doesn't pay attention to our application because we don't expand in Europe aggressively. So right now, that's our, let's say, first year of the startup company, and our full focus is in the United States market. But once we truly decide company-wide to expand to Europe, then we have to take this regulation seriously. We need to do something. And GDPR, everyone gives GDPR as an example when it comes to, let's say, data regulatory requirements. But there are many other regulations in different countries. For instance, if you take India, where Mr. Red resides, then in India, the Reserve Bank of India put the law that requires you and us, the creators of this application, to store payment data in India and not in the United States. So generally speaking, we created the fintech service, and we certainly have the payment microservice there because people sell and buy equities. And according to this law, we can do their transactions processing in the United States. But then once a transaction is processed, we have 24 hours or 48 hours window to transfer and to store the payment data information in India and not in the United States. This is how that law sounds. So generally, from the data regulatory standpoint, if we want to run successfully and expand in Europe and Asia, we need every government to give us a big plus so that we can move forward. This is what we want to achieve. To summarize, okay, Geo-distributed applications. Why would you develop and design geo-distributed applications that run across multiple regions or availability zones? Let's repeat. First, you want to withstand various cloud outages, and we are talking about small and minor zone level outages as well as big incidents. Also, it's always good to serve user requests with a low latency around the globe. And in your case, again, remember the first slide, the globe is the extreme use case. Many of us start small and then grow big, which means that in your case, you want to serve user requests with low latency, at least in your region, whether you're developing for the United States, Europe, or APAC, and then you can grow, right, larger. And finally, if you have plans to expand across continents, or if you already operate in those countries, you have to comply with data regulatory requirements. All right. Any questions, folks? Let me take a pause and let me check the chat and Q&A. Yeah, I see only one question in VCC is also for Cassandra Leap. I don't think this question is directed to me. But I think that if you're talking through Cassandra, yes, you can update. Through Cassandra, you can update your data, and all the changes are going to be synchronized through the Raft consensus protocol. That's my understanding. I was not checking, but we don't have any. I believe we don't have any specific, let's say, right path for Cassandra. Generally, if you use different APIs, but then if you update, you certainly do update this in the consistent way. That's my thinking. That's my understanding. All right, so let's move forward. So right now we know why we decided to put together this workshop because of those reasons. And next, let's take a look at the typical architecture of a geo-distributed application. What are those basic building blocks? Usually when you design that application, you have global load balancer. That's a special component that intercepts user requests at the nearest point of presence, and that load balancer will redirect the user request to the nearest application instance. We will look at this example in the next slide. Also, your application might or might not have the API layer and data streaming layer. It's optional, but usually what I see when many build for the cloud, they build microservices, and microservices need to communicate with each other, and they communicate either through the API layer, like synchronous communication. We can take CON gateway as an example, or they can use asynchronous communication pipelines such as Kafka and etc. And certainly, you're building this application. The application needs to store data, read data from somewhere. You need to have a database, and the database needs to be distributed. So let's have a look at this architecture from the application standpoint, from our application standpoint. Let's say at some point in time in the future, our fintech service will get to this point. It's going to be used around the world. We will have application instances and database nodes deployed all over the country. We will have the load balancer. And for instance, let's take Mr. Green right now. Mr. Green lives in Berlin. Mr. Green opens this mobile application. And this mobile application is connected to the load balancer. And the load balancer comes with a public Anycast IP address. So there is just one single IP address for everyone. And then the load balancer figures, all right, this is the request from Europe. And I have an instance of this financial application in Europe, and the traffic of Mr. Green will be redirected to this node. So all of that is done pretty straightforward and seamlessly. So today, we are not going to talk about, let's say, global load balancers. We're not going to discuss how to deploy the strategies of deployment to those application instances, or how to set up CON gateway if you want to put together communication layer between your microservices. Today, we are going to talk only about the databases, right? Because that's the workshop for the databases. If you want to learn more, just join us because we are going to do more sessions on this holistic architecture. So the first session will take place in person in San Francisco during the Con Summit, but then we will distribute this session and we'll explain everything from top to bottom virtually and in other locations of the world. So now let's talk about database deployments, right? Multi-region deployments of YugabyteDB. So you can have a natural question. All right, these geo-distributed applications, make total sense. High availability, fast performance regardless of the user location, data regulations, and blah, blah, blah. But how do I deploy a database? And there is no a silver bullet solution. Usually your way of thinking is this. Let's say that if you are ready to sacrifice performance in some regions, then you can deploy a single multi-region cluster, a stretch cluster. We will review this use case, all of these use cases. But let's say if you need fast reads in all geographies, then again, you can deploy a single multi-region cluster so that you can withstand region-level outages, and then you can add or sort of attach read replicas in those distant allocations where you have significant customer base. And finally, if you need to deliver both fast reads and writes in all regions, then in this case, you have two options. You can deploy multiple standalone clusters. Those clusters can replicate changes asynchronously if needed, but they're just standalone clusters. Or you can deploy a geo-partition cluster, okay? So let's do this. Let me take a pause here, because next we are going to review all of these deployment modes, and we will do the lab. But now let me show you this application. Guys, give me +1 or high five in the chat window if you have already seen this application demonstration. I want to see how many people who joined us, who joined the workshop, have already seen this application, because it's good to demonstrate how those multi-region deployment types work in practice. All right, I see silence in the chat. Probably, you know what? I'm looking at a different tab. Okay, I need to go here. Yeah, now I'm here. All right, let me show you what it means. This is a bookstore. This is our bookstore. That's a different application. That's not the one that we created so far. And I've got this view. This is the mobile application that is used by the end users. And this is our internal view. We can see the cluster. We can see the user locations. We can see some performance metrics. So right now what we have a multi-zone cluster deployed in a single region in Southern California. That's California, Los Angeles. And this LA, Los Angeles pin means that's one of our users. The user pulled up this mobile phone and right now surfing through the product catalog. So let's see what happens. The user found this wonderful book, The Old Man and the Sea, and decided to buy it. So let's take a look at the latency. So the latency time for the user would be around, let's say, 3-5 milliseconds. And you already know why, right? Because this user lives nearby their primary deployment of our application in the database. Next, let's say this application is becoming well-known. The news spread really fast in the United States, and we've got the user in Washington, D.C. that is in the east coast of the United States. And for that user also opened the mobile application, checks something, founds the book by Franz Kafka, buys this book. And for that user, the latency time is going to be around 70 milliseconds. Why? Because the laws of physics, the traffic needs to travel from the east coast to the west coast, which is fine. For this application, this latency, this round-trip latency is really good. I mean, we are not creating a trading platform, and for this app is more than enough. What might happen next? Our bookstore became a hit in the United States, and right now we are getting the first users abroad. We are becoming recognized internationally. How about London? Someone in London heard about our bookstore, wonderful bookstore where he can find, some premium, nice books. And right now that user also is surfing through the product catalog and decides to buy something. For that user, the latency is going to be higher, around, let's say, 140-70 milliseconds. Why? Because the requests go under the ocean, right? And then once they go they hit the continent, they need to travel through the continent to California. Again, and this is a real application that is deployed in Google Cloud Platform, and we are showing you the real latencies. It's not simulated. That's the real application, the real cloud environment. Finally, let's go to India, to Mumbai. So here we've got another user, and that user is impatiently searching for that book. What was the name of that book? Yes, this Gulliver's Travel. I don't remember. He remembers reading it during his childhood days, and that's the book. Why I want to buy this book? So wonderful. But the responsiveness was slow, because for that user the latency is 2 times higher than for the one who lives in London, because the traffic needs to travel through the land, then under the ocean, and then through the land again. Okay, and what we are going to explore next, different tactics. We are going to look with you at the multi-region deployments with read replicas. So let's say that these creators of Yuga Bookstore had a meeting and they decided, all right, let's deploy a multi-region cluster in the United States for the sake of high availability. And also with that cluster, we will be able to serve user requests from their nearest locations for those who live in the West and the East, but also those who live in the distant locations like London, Mumbai, etc. We will deploy read replicas. These purple dots are read replicas, because what people do most of the time, they check just to product catalog, right? And right now, let's say I'm in Mumbai, the user in Mumbai, and that user is connected to this node, the replica node that is in Chennai. So let's see the latency. The first request will be higher because the connection needs to warm up. But then when I'm selecting, etc., the latency again would be as low as for those who live in the United States, around 3 milliseconds. Good. But if that user decides to buy this book, the latency still will be high, because read replicas, they do not store data. This read replica, the application instance is connected to read replica, but whenever this application sends an update, the read replica node forwards this update to the cluster in the United States. That's why you see this latency. And again, as I discussed while showing you the slides, when you want to boost both reads and writes, you have 2 options with Yugabyte. You can deploy several standalone clusters, independent clusters, or you can deploy a multi-region cluster. So let me show you a multi-region, because this one makes more sense for my bookstore application, because for every location, it's highly likely I will have specific books that are available in that region and available for purchase in that each region. And in every region, there might be special fulfillment centers, etc., etc., etc. So I deploy this geo-partitioned region, and this is my cluster, single cluster that spans around the world. And let's say this node in the United States is going to fulfill all of the requests from the United States. This one in South America will be serving all the traffic and storing all the data from those who live in Brazil, Argentina, Colombia, and other countries. And here is I've got the same node in India that stores the data, and that stores reads and writes for those who live in APAC. So now let's see how the latency will change. The reads are as fast as with read replicas, and then when I buy books, the insert is also fast, because data is local. The data is local. And this is what you can do with Yugabyte, and this is a real application. So this is a quick demo for you, right? What you can achieve with real applications. Now, let's get back to the slides. So the questions, yeah, so Chitan is asking, Denis, can you share the URL for Yuga Bookstore website? So, it's we are going to launch it officially a little bit later. So right now it's deployed in a private network, and it's protected. So follow our announcements. Our plan is to make this application public and be available through the main YugabyteDB website in the coming weeks or month. Okay, so just not yet. All right. So anything else? Let me see. Good. Nothing else? Returning to the slides. So YugabyteDB. YugabyteDB doesn't need an introduction in this session, but anyway, I'm the guy who likes to repeat stuff, and this is my quick definition of YugabyteDB so that we are on the same page with you. YugabyteDB is open source distributed SQL database, and two things that, if you need to remember two things about YugabyteDB, Those are my two favorite. First one, it's built on PostgreSQL source code. Literally, we use PostgreSQL source code. We are built on it. And also, our distributed storage layer, we will remind you Google Spanner-like architecture. YugabyteDB was inspired by Google Spanner database. How compatible are we with Postgres? I think that some of you might have attended the compatibility talk that we had today, but generally speaking, let's, if you want a speed dating-like experience with that compatibility in YugabyteDB, what you see here in blue, Postmaster, Rewriter, Optimizer, Planner, Executor, that's Postgres. This is Postgres, and this is what we have in the YugabyteDB code base. And these little green, orange rectangles are several optimizations and enhancements that we introduce into the PostgreSQL code base so that Optimizer, Planner, and Executor can efficiently run distributed SQL queries over your YugabyteDB clusters. So this is, but generally we are Postgres with a lot of enhancements related to the distributed storage engine. Okay. Now, let's finally talk about different types of multi-region deployments. It's 30 minutes after the workshop has started, and we have not touched any code yet. First one, single multi-region cluster. Again, pros. What are the pros of the deployment? You can scale horizontally. I mean, you don't need just to try to predict or estimate, to do your best effort trying to estimate what would be your workload in a month and half a year and a year. With YugabyteDB, you know that you can scale, right, horizontally and vertically, right? That's the pro. This actually characteristic applies to all of the types of multi-region deployments. We are sorry, we are listing it here just for reference. Also, with this deployment, why we have it, we can tell the regions. Yep, sorry, let me do this. All right, I'm back. With this cluster, we can tolerate region level outages. Remember the first slides that explained why would you use YugabyteDB, but also the cons. What are the disadvantages? If you would have users that live far away from your primary cluster deployment, then the latency will be high for them, right? Something like for Mr. Green and for Mr. Red. And data residency requirements are not fulfilled if it's important, right, for your application. Mr. Green, his personal data and the payment data of Mr. Red will be stored in the United States, which violates the GDPR and the regulation of Reserve Bank of India. Also, what's interesting about multi-region deployments and just multi-AZ deployments, in YugabyteDB, you can define a preferred region. And a preferred region lets you define a node or like a region where you deploy a node or several nodes that will keep the primary copies of your data. And usually you do this because you might run some complex operations. You can run joins, you can run multi-step transactions, multi-step business operations that need to read data, update, do something else. And you want to minimize the traffic across regions. And when you define a preferred region, all of those multi-step requests, etc., will go to one region by default. Everything will be read and updated first there, and then the changes will be distributed through the RAF protocol to the other nodes in different regions. It's in practice, it's more efficient. So let's take an example. Like by default, right, when you do not specify a preferred region, all of the nodes will be keeping primary copies of the data as well as backup copies for some other records. Let's take an example. You have this node that is deployed in the US West. And this node keeps the primary copy for the record with ID 1. And the backup copy for this record is located in the East here and in the US Central. But also for the record number 3, ID number 3, the primary record is in the US Central. And for the record with ID 2, the primary record is in the West. What it means? It means that whenever our application, our financial application, connects and wants, let's say, to post any just to close any deal for Mrs. Blue, if that information needs to be, if that information is related to this ID number 2, then the request will go here. If, let's say, the application needs to get or update the record with the ID number 3, the request will go here. So that's how it works. With the preferred region, how is it different? Every node will keep a copy of your record when you set the replication factor to 3. But I said that US Central is the preferred region, which means that the copy of the data that is in that region is the primary one. All of the requests by default, reads and writes will go here. And when you do write, you first update here, and then this node will distribute the change through the RAF protocol to the other nodes. So this is what you can do with preferred regions. Okay, so let's now go to the lab. And again, guys, if anything is not clear or you have any questions, I'm checking the chat and checking the Q&A tab. Feel free to ask. So the lab, let me post this gist with you. Feel free to follow me. Let's do this. In the chat window right now, you've got the link. If you do plan to follow me and you will be trying to reproduce the steps on your end, then give me +1 in chat so that at least I will see that there is at least someone who would like to repeat the steps. If nobody responds, that I will just move forward at my own pace. Okay, check it and give me share your thought. So first one, let's start. We're going to use Docker because this is actually the technology that allows us to test YugabyteDB and other applications in the cross-platform way and really quick. Instructions might look scary to you, but again, this is for the sake of the lab so that you can understand the internals. Then when you go in production, it's up to you. You can deploy YugabyteDB using YugabyteDB anywhere. That is just, click, 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 click interface. So you can just go to YugabyteDB manage. Again, click, click, and your cluster is going to be managed. Or you can actually take these instructions and deploy them manually and maintain. It's up to you, okay? But today we are going to deploy everything manually. So let's create first this network. Where am I? Okay. And this network are all of the containers are going to run in this network and my application. And next, what I'm doing, let me copy this command and start it, and then I'm going to explain you. I'm starting, as you can guess, a 3-node YugabyteDB cluster. We are going to have YugabyteDB node 1, the first container, and the second container. The second container will join YugabyteDB node 1. And the third one will join the YugabyteDB node 1. So generally, we are going to have a 3-node cluster. So let me check the Docker. The nodes are running. So now, next step, let's connect to the cluster using PySQL. I think what's interesting, if the latest macOS is an exciting piece of software and hardware, but sometimes it takes time to start everything through Docker on Apple M1 machine. So let me see whether it's started or not. Okay, the first node is started. I guess the second is also going. Yeah. Usually that's what I experience on my hardware. Apple M1 is still yet to be supported. All right. I'm in. And we can right now execute this service system function. Select Yugabyte servers, and we can see the state of our cluster. Select from, sure. So what you can see, we have this 3 nodes cluster, and by default, even when you don't specify a region, every node in the configuration has the notion of the cloud region and zone. So by default, YugabyteDB assigns some default values. By default, you're going to run in some custom cloud 1 and data center 1 and zone, which will equal to rack 1. So this is what happens by default, okay? Also, what you can use if you use YugabyteDB open source, the database is fully open, and we also do our best to release and to make available the UI so that you can monitor your cluster. So if you go to this interface. You also can see details of your cluster. Here are the same cloud region, cloud 1, data center 1, rack 1. Basically, it said that like all of those nodes are deployed in the same rack and in the same on the same basically server in the same data center, the same cloud, which is not a highly available solution, right? If the rack goes down, we are down. So next, we discussed that we can deploy our cluster across multiple regions. When you deploy this cluster in the real cloud environment, like what I showed you with this Yuga Bookstore deployment, or when you use YugabyteDB managed, etc., what you do, you just do the button clicks and you select your cloud regions and you deploy your clusters in specific zones and regions, etc. In our case, we are going to do this differently. So let's change those custom regions. I want to deploy my nodes. I want to place my nodes in some specific in different regions. So first, let me remove these containers. Their lifetime was short, unfortunately. And next, I'm going to deploy a different cluster. Again, still 3 nodes, but a little bit different configuration. So let's see at this configuration, what's different. I'm defining the custom placement info. I'm saying that this node, YugabyteDB node 1, should be placed in this in their AWS region, US West, zone A. And these names, you can put any custom name. I mean, especially when you deploy in Docker or you're in your premises, it doesn't need to match the name of the real of the regions and zones in AWS. We are doing this, just for the sake of a demonstration, because if you decide to deploy another node in the same region, those nodes will belong to the same region, right? And there are cases when you want to do this. And the other node is deployed in US Central. We are saying that it will be placed in the US Central region, and the last one is in the US East. So now, once you do this, then you need to execute this command. Let me run it and then walk you through it. This command connects to the container of YugabyteDB node, and on that container executes a YugabyteDB admin tool saying that, all right, all of these masters, the master process of YugabyteDB, we have three nodes, and every node also runs this T server that stores your data and processes requests, and you have the master node that is responsible for different operations related to DDL, etc. We are saying that, hey, modify placement info. So right now our cluster runs in these 3 zones, okay? 3 zones and the replication factor 3. So this is what you did. Now, if you connect to the same cluster, let's use PSQL for the sake of consistency. And if you run the same command, you'll see that right now I have the same node, but they are deployed in the different region, right? And again, we are not running these nodes right now in the real AWS environment, but it shows you how you change it. If, let's say, you would deploy these nodes in the real AWS environment, like using YugabyteDB anywhere, YugabyteDB managed, then in fact, the region, the zone, and cloud names will match the real zones and regions of AWS, and they will be placed in those real regions and zones. In Docker, we are just testing the waters. And now let's refresh our UI. You can see the same statistics here. Node 1 is US West. Node 2 is in the East, and the last node is in the second is in the Central, and the last one is in the East. Good, right? That was easy. This is how you can change your regions. For instance, by default, it's going to be deployed somewhere. And then if you want to change the placement info, if you want to decide where to place the nodes, etc., this is how you can easily change your placement information. And now we talked about that financial application, right? And that was not a joke. let's deploy the first version of this market order application. So right now, what the application does, the application connects to a special financial order stream, captures different trading information, stores this information in YugabyteDB, and also it will print different statistics such as the most popular stocks and blah, blah, blah. So this application is available through GitHub. It's open. Right now, we call it the Market Orders app, the simplest app you can create with YugabyteDB, one of the simplest apps. So let me open another terminal window. I will go to the temp directory on my machine, and I will just clone the application there. Oh, wonderful. Next, it's in Java, but we have actually, if you are Python Node.js developer, we have the same version of the application created for those programming languages. Just go to YugabyteDB developer hub through the website, and then there you will find our reference to our GitHub, and there you will find market orders application for your programming language. So Maven clean package. Let's assemble the app. What? Yes, market orders app. We are going into the directory. Let's assemble the app. Good, no issues. And now, again, the application, I'm going to deploy it in Docker in the same network where I run my YugabyteDB cluster. Let me create an image. Ready? And finally, this is a Squarian long string startup string. I will start this app and I will explain you what happens. The first line, we are going to run our market orders instance from this image that we have just created. It's going to be deployed in this YugabyteDB network where we have our cluster running. This is the jar that is inside of the container. And then we have properties for the Docker, how to connect to YugabyteDB instance in the Docker. Next, we have just this schema Postgres. We created two tables, buyers and trades. And we are saying that, again, the application connects to a remote service, really remote service, captures trades from there and puts into Yugabyte. And then every 5 seconds, we are going to print these statistics that you see on the screen, like the most popular stocks like Apple, Linen, Google, Ethereum, etc. So we just have 5 stocks, dummy data. It's not a real market orders data, just some sample data, some sample data set. But anyway, let's now go to the YugabyteDB because we deployed a multi-region cluster. And every node, you remember that slide? Every node by default, we don't have a preferred region, which means that every node will be keeping a subset of the data for which the node is primary for, which means that every node will be handling reads and writes for certain subset of the data. Let's go to tablet servers. And here is node 231. You will see that reads and writes, the nodes are under the load. And every node takes part in the reads and writes, which means that we try to distribute our data evenly, and every node is processing your requests. Wonderful, right? So this is good. This is done. So this is how we deployed our multi-region cluster across several regions. And right now you can see that every node is every region and every node is equal when it comes to their data storage and processing. Okay. Then if you decide to change, if you decide to set a preferred region, then we don't want to do it. We're not going to do it today. I just want to shorten the time. You will have the link to this lab. You can try this at home. That's let's suppose that's your homework. You can change the preferred region this way. First, you can say that, let's say, the US Central Zone is going to be the main preferred region. If this zone goes down, the secondary preferred region is West and then East. You do this, and then over the time, you will see something like that when a node 2 from the US Central bits that we set as the main preferred region, it's going to be leader for all of the data, for all of the tablets, for all of the charts, and it's going to execute and fulfill all of the reads and writes until that region is down or until you change that preferred region. Okay, so try this home. But what I want to show you right now, because multi-region deployments, if you remember, the very first reason why we need those is high availability. You remember, right? When we created the first version of our application, we deployed it in a single cloud region in there, and that natural disaster, swiped our region, and the application went down, and Mrs. Blue, who lives in New York, was disappointed, extremely disappointed. She wanted to close several deals. She wanted to buy some stocks, but the application was down. That was disappointing. And right now we are running across multiple regions. Okay. Every node, just to remind you, runs in one of the regions, central, west, and east. And let's try to simulate. Again, we are trying to simulate the outage. What we can do, the simplest approach, we can simulate the outage of the US Central by stopping node 2, because that's the only one node that is located in that region. So if you stop that node, effectively, you can pretend that you experience the outage in the US Central. So let's not waste a minute, and let's stop this node. All right, that's my PSQL session. Stop this node. So it's down. Good to see. So what else? Here is my application is designed in the proper way, because some of the connection I'm using, I will show you actually the source code. Some of the connections we open to this node, and it's inevitable then some of those connections were lost when the node went down. But the application is smart. It processes different error codes, and there was an error code saying that, all right, that connection is dropped there because the node is no longer available, and I'm basically taking another connection from the pool. So basically the application is not impacted. The cloud is down. Not the cloud, actually, that region is down. Let's see. So here is, you see that the node is still labeled as alive, but the last time it responded to the heartbeats of the other nodes was 45 seconds ago. Generally in Yugabyte, by default, YugabyteDB cluster gives a node 60 seconds to return back to the cluster. If the node doesn't return during the time frame, it's more than 65 seconds, it's dead. So the node is officially down, but the application is running. Wonderful, right? So also what I wanted to show you right now, let's say that everything, like all of those regions, the stuff goes down, but then the smart folks, step in and they fix stuff. So that region, let's say that region was restored. The region was restored, and we can restore the region by bringing node back to the cluster. And we use this command, right? We're just starting our node. While that node is going to be started, I promised you to show the source code. Sorry, for that application. So why the application was not impacted when the node was down, and why the application, just elegantly switched to other connections, to the other nodes. So here is in my properties file, I'm using what? I'm using the Docker template for this application, because the cluster is in Docker. So here is, I'm using YugabyteDB cluster aware data source, and I'm saying that my primary connection, my primary node, one of the connection endpoints is YugabyteDB node 1, west, and then node 2 is another connection endpoint, central zone and central region, and node 3 from the east. Okay, so generally, and that connection pool has up to 20 connections. So generally, my application, when it started, it initialized the pool, and the pool had 20 connections. Some of those connections were opened through this YugabyteDB node. That's why when that node went down, it's inevitable that those connections were lost. But my application is smart enough. It processed a special code, and it reconnected and asked the pool to recreate the connection, and the pool used other endpoints that were alive. Good? Makes sense. Hope makes sense. If anything doesn't make sense to you, the Q&A or chat is open. Okay. Now the node is back. All right. The node is back. Let's quickly check here. It's back and it's alive. And what's good, it's already processing reads and writes. So it's back in game. And this is that was the outage simulation. And you see that the region was down, the region was up, the application was running all the time. So this is the benefit of a multi-region deployment. And we have our custom regions. So what's next? The next topic is read replica. Before we do this, right now, let me stop this application. I no longer need it, at least for the next 10 minutes. So let me close some of these screens. There are too many of them. Let me clear this stuff, and let me pull up the deck. Where is my deck? No, this is this. That's it. That's it. So, folks, any questions while I'm refreshing myself? All right, I don't see any questions, which that's wonderful. Looks like all of you are very well prepared. So hope that at least you will be learning something new from me. At least you will learn about these wonderful users, Mr. Blue, Mr. Green, and Mr. Red, and how they used our application. All right, let's talk now about the second type of multi-region deployments. We discussed single stretch cluster, and we also discussed our single stretch cluster with preferred region. Right now, let's talk about read replicas. When would you use those? Pros, again, same as with that stretch cluster, it's scalable and fault tolerant because a read replica is attached or plugged into one of your primary clusters. And second, with read replicas, you can truly deliver fast reads in distant locations, in locations that are distant from the placement of your primary database nodes. But also cons, what are the disadvantages? The write latency is not solved because the read replica cannot process write. The read replica basically forwards all of the writes to your primary nodes. Data residency requirements fulfilled partially. What I mean, because read replica for Mr. Green certainly going to keep his personal data in Europe, but also same data will be stored on one of the primary nodes in the United States. That's why partially. And changes sent asynchronously to read replicas. So you will not have, let's say, up to date. There will be some lag because the changes come to the primary cluster first, and then they are replicated asynchronously to your read replica nodes. Well, so, and why do we do this? Why do we want to deploy read replica cluster? Again, our market orders fintech application became a hit in the United States, and now it's recognized internationally. And we want what many users do all of the time. They open first before buying any equity, right? Before selling, before doing any changes with their portfolio, they want to see the state of the market. They want to read the news. They want to read different reports by analysts, which means, and all of those are read operations. That's why before people click sell or buy, etc., in my app, they will be reading stuff, right? That's why read replicas is a natural solution when you want to introduce performance improvements to your geo-distributed app. And with YugabyteDB, it's literally really fast. Like I already have what we will. Right now, we will switch to our lab, and you'll see that it's extremely easy to attach a read replica node to your live production cluster. It's literally, you can do this within a day, a week. It depends on like what's your process for the infrastructure and application changes. So let's, again, that's it from the theory and blah, blah, blah perspective. Now let's, let's go back to Docker. This is what I like. Okay. So our lab, step number 4, section number 4. We are not going to start the cluster. We already have the cluster, in fact, and this cluster is in our United States location. But I want to deploy a read replica node in Europe. So first, what I am going to do, let me execute this command and I will walk you through it. So what this command does, again, we are connecting to the container of YugabyteDB node 1 that is in the US East, sort of in my Docker. And then I'm executing this add read replica placement info through the UB-admin tool. And I'm instructing, I'm telling my cluster that, all right, I've got a new location. It's going to be AWS Europe West Zone A, and the replication factor is 1. There, I'm going to have a read replica node. Okay, and that's just UUID for my read replica nodes. So this is what I've done. And next, this scary long command starts a read replica node, and it attaches this read replica to the cluster. If you're familiar with Docker, it will make total sense to you. So again, I'm starting this read replica node in the Docker container. It will be running in the same network where I have my primary cluster and my application. Next, the image, the information about the primary cluster master, and then the placement. The most important is the placement info. I'm saying that this one is going to be located in Europe West. Good. So looks like the replica is running. And now if I refresh the screen, this is my replica. Congratulations. And this replica is in the AWS in Europe West. Job done. Almost job done. So how do we test it? So we've got it. We deployed the read replica. So here is, you will not be able to see and experience the real latency, but again, I showed you store, and you saw how the latency dramatically improves when you attach a read replica in the real location. Today in the lab, we are not going to see like this latency difference because everything is running in my and your local machine, but we want still to experiment, to play with this replica node. Let's do this. So next one, let's execute several queries through the replica, because when you design your applications, you need to know how application needs to interact with the read replica. So first, what I'm doing right now, I'm connecting to this YugabyteDB replica 1 container. I'm in. This is my container. This is my home directory. And then I'm using YSQL SH tool to connect to the read replica. If you're not familiar, YSQL SH is basically our version of PSQL. Okay, so just this is what we do. This is what we have, just in case. And it's shipped with a default package of YugabyteDB. So I'm in. So here is, again, as with the first cluster, let's check my servers. That's my cluster. All right, I have node 1, node 2, Central, West, East, and this is my replica node in Europe West. Good to know. Also, remember this, at least one thing that you need to remember about read replica from the application standpoint. Even if your application is connected to your read replica node, and if you start sending reads through that node, if you need to enable 2 parameters. If you don't do this, then read replica will serve reads from your primary cluster. And those parameters are this. You need to tell that you need to set session characteristics to that's first, saying that for this session, for this connection, we are going just to run reads. We're not going to do writes. And then you are saying that, yes, please allow reads from followers for this connection, right? For this particular connection. And this one, like a read replica, is obviously a follower, meaning that read replica is attached to my primary cluster, and it follows all of those updates. It receives these updates, and I will be reading this data that can have some lag when it's compared to primary data set. Okay, I'm connected, and right now I have this table, right? Let me see the structure. All right, tables. I have some views. I have such. So I read this information through the replica, and now I have this trade table that keeps all of the trades. I have almost 2,000 trades in my database, which means that after the replica was attached to the cluster asynchronously replicated the changes, which is good over the time. Now, what we want to do, we want to start back my application, because right now the application is down. I don't know why I stopped it. I could have connected the read replica to the cluster with the application running. So this exception is harmless. The exception basically says that the database has already created. We have the sequence, and it basically skips this database initialization step. Right. So right now we are creating the new. We are again capturing different traits. We are inserting these traits into the database, and also then over the time or once some different buffers are fulfilled, the changes will be transferred asynchronously to the replica. So let me see what's happening here. So now if I go to my read replica, you see that the changes are coming, and the changes are delivered asynchronously from the primary cluster to the read replica cluster. Okay, taking a pause and just in case checking your questions, if any. Okay, no questions. Okay, guys, at least I hope you can hear me. All right. Okay, so what's next? Also, what's interesting about the read replicas in YugabyteDB, because YugabyteDB is not the only one database that comes with the concept of read replica, but our read replicas allow you to serve. You can send writes and you can do updates through a read replica node in YugabyteDB. And this feature is unique. I think it might be supported by some other databases, but usually that's not the case. What are the benefits here? Let's say that you have your application deployed in Europe, and Mr. Green, who lives in Berlin, the scientist from Berlin, he will be connected to that instance of the application through his mobile phone, and that instance of the application will be connected to that read replica node. You don't need to have several connection points, just to the read replica node. And whenever you do reads are served from the read replica node. And when you do writes also can be served through the replica. But the replica will forward those writes to your primary cluster. So let's do this experiment. Let's see who are the buyers. We are going to have several people who buy stocks. And now let's try to insert someone else It says that it's like the read-only connection. And if you want to allow writes through this read replica connection, you, at least temporarily, for the time while you execute insert, you need to set this instruction characteristics as transaction read write. Or we have a similar command, but per operation, if I'm not mistaken. You can find it in the docs. And then execute this insert this data. And after execute insert, you can just roll back so that you can you keep reading the data. Now, if you run this, you can find where is insert gem. So it looks like it's not replicated yet. Where is my gem? It was inserted. Insert buyer gem. Yeah, looks like in my Docker environment it takes time. Yeah, it's here. Because read replica accepted this request. You remember, right? Because that's the connection through read replica. It sent this request to the primary cluster, and then the primary cluster finally, in several seconds, like 10 or 20 seconds, asynchronously forwarded this change to my read replica node. So this is how it works. These are the read replicas. All right. So what else? Let me. By the way, guys, tell me this. Write down like your what's your multi-region? What's your deployment of YugabyteDB? Does any of you run YugabyteDB in across multiple regions? And does any of you use read replicas? I'm just curious about the statistics. Just share your thoughts in the chat window. Curious to see like who already uses YugabyteDB across multiple regions and who already uses read replicas. In the meantime, let's proceed with the next. So we talked about multi-region clusters. We talked about preferred regions in those multi-region clusters, and we covered read replicas. We saw how those read replicas works. Now, let's take this case. We solved the problem of slow reads with read replicas. But right now, we want to boost both reads and writes. So what can we do? Again, as it was said, in YugabyteDB, you have two options. as with many other distributed SQL databases, you can deploy multiple standalone clusters. And this is what we did here. For instance, we have a cluster in the United States that stores all the information for those who live in the US. We have another cluster in Europe, and we have another cluster in APAC. So this is what we've done. All of those clusters are scalable, fault tolerant, they can serve fast reads and writes, and they certainly can comply with data regulatory requirements, such as like all of the personal data of Mr. Green and all of the payment data of Mr. Red and the folks who live with him will be stored in these specific locations and not in the United States. As for the disadvantages, and those might be disadvantages or might be just neutral things for some of you, if you need to replicate, you don't need to enable any replication between these clusters because they're standalone, but if you need to replicate changes between these clusters, it's going to be an asynchronous replication, so like expect some data lag. And another one that might be a significant showstopper for some of you when it comes to this deployment is that if your application needs to take data from several locations, for instance, I'm collecting reports from the United States, Europe, and APAC. I need my application to connect to these clusters. You're going to use third-party applications for cross-cluster queries. You're going to use third-party solutions, or you're going to implement something on your application layer if you want to query data from these different locations, and then you need to merge this data. It's all on you, right? So this is what is not supported here. Or you can use some, let's say, solutions for federated queries. Now, let's see how you deploy it. Again, if you use YugabyteDB managed or YugabyteDB anywhere, it's really quick to deploy the standalone clusters. But we are not looking for the easiest ways. In our lab, what we have, let me stop actually the application right now because we are going to shut down the container of the Replica. We are going to shut down the app. We are going to shut down the cluster. We are going to chapter 5 of the lab. Let's shut down the existing multi-region cluster and use another set of commands to deploy a cluster, standalone clusters. So right now we are going just to have, again, for the lab is enough to deploy 2 nodes, and each node will be located in its own cluster. So like we are starting YugabyteDB node 1, it's going to be in the US West, and YugabyteDB node 2 is going to be in Europe West. This node do not join each other. Those are going to be separate nodes and separate clusters. Okay. So let's start this. So let me see. So node 1, I'll let my Docker on my M1 machine to warm up a little bit. Yeah, okay. Starting, finally. If you use on your machine, I mean, the experience should be completely different, especially if you're on Linux or on Windows, so probably not M1 version of Apple. Okay, I think it's gonna be ready. So what we can do right now while that is being done, and now I need to connect to every cluster, to every node of this node, and change the information. The first node is in the US West, and the second node is in the in Europe. Okay, now we have 2 separate screens. One is going to be for the first cluster. I think I just need to refresh this one. I have just 1 node, and this node is in US West. So you can always deploy as many nodes as you like, but again, let's not complicate in here. And this one that listens on the port 7002 is for the second cluster. I node 2, yep, it's in Europe. Good, done. So we started 2 separate clusters in Docker. In general, you can leave it as is. So right now you can create your application instances. One application instance will connect to the US cluster and will serve all the traffic for the US, and the other one will be used. The other cluster will be used for the European customers. But let's take another example. Let's say that you want to enable replication between your clusters, and if you do this manually, YugabyteDB supports two types of replications. You have bidirectional, master or active replication, or you can have unidirectional or active passive replication. In this lab, we are going to configure the unidirectional replication. So this process involves several steps, and it's a little bit it has several steps, and when you do this manually, you just need to follow this stuff precisely. So first, what I'm going to do, I'm going to enable unidirectional replication from the United States to Europe. So like generally what it means, whenever anything is going to be updated in the United States, those changes are going to be replicated to Europe. But if you update anything in Europe, those changes are not going to be replicated to the United States. So this is what I'm going to achieve. So first one, right now the cluster is empty. So let's, what we need to do, we need to connect to each cluster and create the tables, the schema. Because right now, as of now, our X cluster replication, that's how we call this replication in YugabyteDB, does not replicate DDL. So let me connect to the cluster, to the first one. Let me create this table. In the first cluster. In the second screen, let me connect to the second cluster. The first cluster, how do I do this? Because I'm connecting from my host machine. The first cluster listens on the port on my host machine. The first cluster listens on the 5433, the second on the 5433. So this information is in this Docker command. So when I was starting the first node of this first cluster, I said that, yeah, this is my internal port in Docker, and the same port will be used in my host operating system. But when I was starting the second node for the second cluster, again, that node uses the same port internally in Docker, but in my host operating system is going to be 5434. So that's it. And let's now create the same table in here. After that, let me keep this PSQL sessions opened and create another tab in terminal. So what I'm going to do next, we need to instruct the cluster to replicate changes for this trade table. And again, it involves several steps. First, we will connect to the cluster. We need to get the trade table's unique ID. So I'm connecting to the container, to the only one node of that cluster as of now. Not the most high level, not the most fault tolerant solution, but it's good for your local Docker deployments. And now I'm executing this command, and this command returned me the unique table ID for the trades. Okay, this is it. And also I need to know the unique cluster ID for my US-based cluster, for the cluster that is going to replicate changes for the cluster from which I'm going to replicate changes from. So, and for that, there are several options, but you can use kernel, you can using this command. So this is UD. And actually you have the same cluster ID in here if you want to, if you prefer UI. The same ID, yeah. And now set up the replication. The final step, finally we've got there. We need to set up the replication from the United States to Europe. So let me do this. Yes, so let's have this trade ID, right? Have this trade table ID. And we have this cluster ID. Source cluster ID. other number. Okay, that's the roadblock for me. Okay, let me do this. Nana in this container. Nana is there. Command. So when you think that everything is going to run smoothly, then you can come across some unpredictable and see things. So this is my table ID and this is my cluster ID. And now let me copy this command. Now let me execute this command. Replication set up successfully. All right, it took me almost 2 minutes, but the replication is ready. So now let's do the test. This is my United States cluster, I guess. Let's do the check. YugabyteDB servers. United States West. And I guess this is just in case they're Europe. That's the European cluster. So what we are going to do now, we are going to the United States cluster, and we are inserting the first trade into the table. Okay, the trade was inserted, right? And we have this. Someone purchased five stocks of Google. It's kind of it costs a lot right now these days. And let's check this in the second cluster. The change was replicated from the US to the United States. Okay. So this is how it works in practice. But right now, you remember that we set up their active passive replication unidirectional from the US to Europe, but which means that if I close any deal in Europe, that deal trade it's not going to be replicated to the United States. So right now I'm in Europe, just confirm. That's Europe. And if I insert this trade, someone decide to buy Tesla, because I still believe that it's a good opportunity to buy Tesla right now, considering the price. And this stock is here. I know that's a wrong request. So that's in Europe. You have the Tesla, and that's the previous trade. But if you go to the United States, the trade for Tesla is not there because there is no any replication link from Europe to the United States. Again, if you want to have active, you can do this. But in this case, we reviewed how to do this unidirectional replication. Hope it makes sense. So this is basically what you need to know. And you would use this multi-region, multiple standalone clusters if you want to serve reads and writes fast. And if you also want to be highly available, if you want to comply with data regulations, and generally when your application doesn't need to run requests across different regions, across several clusters, that's probably the best use case for you. But now let's review the final type of deployment, which is the geo-partition cluster. Before jumping to the lab, let's return to the slides. Because this actually type of deployment makes sense more for my application, because I need to have a view into this global state of the market. I want to run some internal reports. I want my users to see what's happening in their Hong Kong market. I want to see what's happening in the London Stock Exchange, New York Stock Exchange, which means my application wants to connect to all of those data endpoints. And I don't want to my application, my mobile applications, or my backend to maintain different connections to various databases. It might be, let's say, error prone and hard to support, which means that geo-partition cluster was the difference from the previous one. Again, as the previous deployment option, you actually also scalable, fault tolerant. You can serve fast reads and writes in all locations, and you can run queries across all of those locations, but at high latency, that's for sure, because you can, if you need to pull data from various continents. The only one disadvantage that might be disadvantage or might be not disadvantage is that at your application level, you have to introduce a special count. It's called, I call it a geo partitioning column. And in this my application, in this market orders application, the name of this column is the region. And basically how it works, if you insert data or if you request data and the value of the region is set to the United States, then the database will read the data from these nodes. Or if you are trying to insert a trade for Mr. Green, who is in Berlin, then the region will include EU, European Union, and the value, and the trade will go and will be stored on these nodes that belong to this region. Okay. We are not going to dive deep into the details. Usually how it's implemented, if you're interested, we use the features. This capability is based on the two features of Postgres. We use table spaces and partitioning. And you will see how these table spaces are configured, etc. Basically, with table spaces, you define those different locations like European Union, APAC, and the United States. This is the first one. This is the Postgres feature that we use for this geo-partitioning use case. And then for the partitioning, we are saying that if, let's say, we are partitioned by list, this is how it's called in Postgres. We are saying that if the value of the region, of this column region, is equal to the European Union, then the data is going to be stored in this partition. And the partition is basically a subtable of your primary table. You'll see it. I'll show it to you guys. So this is all you need to know, at least from the beginning, when it comes to this deployment option. And if you remember our application, this is the application this is the type of the deployment that we used in our application to boost reads and writes globally for this Yuga bookstore. I showed you the use case for Mumbai, but if I, let's say, jump to Sao Paulo, let's go to Sao Paulo. And this is my node that serves the traffic, that keeps the data for everyone who lives in Latin America and South America. And now let's see the latency time. So I'm serving through the product catalog. I'm reading different books. The latency for it is fast because, let's say, it's here in South America. If I want to buy this book, the purchase is going to be fast as well. It's all around 5 milliseconds. Here. So this is how you can boost reads and writes with this. And this is the real cluster. It's not, let's say, something what I run in my lab. It's not Docker. It's a real cluster, real application that is deployed in Google Cloud environment. It's like all live. That's why all these latencies are true. Those are true latencies, folks. All right. Now returning to the lab. I need to do a little bit of housekeeping. I need to clean and destroy some of these tabs. I no longer need them. Terminate. So where am I? Is this my machine? Yeah, that's my host machine. All right, let me start the previous cluster. I want to start with a fresh setup in Docker. Only the application can remain. And now what we are starting again, we are starting a two-node cluster. That's going to be a single geo-partition cluster. We have YugabyteDB node 1, we have YugabyteDB node 2, and YugabyteDB node 2 joins YugabyteDB node 1. It's going to be a single two-node cluster. Not the most typical configuration deployment, but that's more than enough for our experiments. And I'm saying that the placement info, node number 1 is going to be in the US West, and node number 2 is going to be in the Europe West. Let's start it up. Okay. While it's gonna be loaded, let me take a pause. Okay. Waiting. And once also as with previous deployments, we need to change. We need to inform the cluster that modify the placement info, saying that these are the regions where our cluster is going to be deployed. 2 regions, only 1 replica in every region, and the total replication factor is 2. Again, not the most typical one, but enough for the demo. Now let's get to this one. Yeah, we have 2 nodes, US West, Europe West. And what we are doing next, let's connect to, let's say, one of the nodes. Come on, I'm still connecting. right, I'm here, I'm in. As before, let's run the same dial, check that I'm not cheating here, and that's the same cluster. Yeah, 2 nodes, Europe West, US West. What next? You remember I talked about table spaces. So right now, if you want to use this geo-partitioning, when you want to place the data based on the value of your geo-partitioning column, first you create table spaces. That's the feature of Postgres. And Yugabyte, as a Postgres compliant database, just supports it, inherits it by definition. So we have the first table space for the United States, saying that all of the nodes that are going to be placed in this region, this zone, are going to be in this table space. And actually, not the node. Actually, not the nodes. It's like it's for the partitions that we are going to create below. And this table space is for the data for the partitions that are in Europe West. Okay. Going down, so now we are creating this table, trade table. So how this one is different from the example that we did with 2 standalone clusters. The same structure except for this one, partition by list. Again, this is the key word of Postgres. It's not created in Yugabyte, it exists in Postgres. And we are saying that this primary table, top level table, is going to be partitioned by list, the list type of partitioning, and this is our partitioning column. Done. I think that this is how you can check next. Let's check for this table. Yeah, we are saying that we are going to partition by key by this list. Next, let's create those partitions eventually. We are creating 2 partitions. The first partition is for the trades that are in the United States, and this partition is going to be in the USA table space. And this USA table space is for this region. And in that region, we already have node 1. So this is the connection, right? So how the data that you create, how partitions that you create using this DDL are actually mapped to physical nodes that are already running in a specific region. Okay, and now if you execute the same command, you'll see that, yeah, we have 2 partitions. So we have the first one partition for the trade Europe for the values. If, let's say, the region column is Germany, France, or Italy, then the data will be in this partition. Otherwise, if it's the United States, it's going to be here. Now, and just in case, folks, partitions, like when we're talking partitions are ordinary, sort of ordinary tables in Postgres. For instance, you can do the same operation, trade Europe for the embassy, like the same table. It's just, you know, it's attached to the primary trade table. But you can always query those tables directly if necessary. But you can do if necessary. Now, let's do the test. Let's insert some data in Europe. This command inserts a trade. Someone sells Tesla stocks. Probably that same guy that bought Tesla right now sells Tesla. And that trade takes place in Germany. We sell this trade. Right now, if you request, let's do this. First, let's request this data from the top level trade table. So this is actually what your application is by default. Your application instances, right? You have application instances in the United States and Europe, and those application instances are most likely are not gonna query trade underscore Europe or trade underscore US. Those applications are going to query the primary table, the top level table directly. And you can see this trade, but where the data, where that trade ended up being, let's query. For that, we can do this experiment and query this trade Europe partition / table directly. It's in here. It's in this partition in Europe. Let's make sure that this trade is not in the United States. So generally, imagine this is what you did with this Yugabyte bookstore application. All of the data that belongs to South America and Sao Paulo, etc., it's going to be located there. It's not going to be located on the nodes that are in the United States or Australia, because this is how we can do this with our geo-partitioning columns. So next, if you explain analyze, actually, let's do this explain analyze. If you request, say your application runs in Europe, and you know that that instance of the application in Europe, you can say, I want to request all the data for Germany, where a country, you don't need to query trade _ Europe here. For the sake of simplicity, you can say where a country is Germany. You are going to get this record back, and let's show you what Yugabyte did. Yugabyte actually internally, even though you were querying the trade table directly, our application, internally YugabyteDB just did the partition pruning and requested only the trade Europe partition. It was not requesting data from United States because you specified this label. Whenever you need to query global data, let's say you want to get all of the trades from all of the countries, you just do this. You don't specify the country. And in this case, we are going to query all of the partitions. So this is how it works in Postgres, and it works in YugabyteDB. The only one difference that in YugabyteDB, it works across this geo-partitioning standpoint. All right. Okay. So what's left? I would say that right. We are almost done, folks. We have 25 minutes left, and we are going to wrap up. So what we discussed, this workshop was about multi-region application deployments. And to summarize, multi-region application deployments are used especially by geo-distributed applications, the apps that run across multiple regions availability zones. So if you're kind of sitting right now and scratching like, how do I start architecting or building those geo-distributed apps? Probably I'm just creating my application. I don't have a need to run across multiple distant regions. I don't need to run, let's say, across several countries. But then how do you start? Still, please at least deploy across multiple availability zones. That's a good architectural decision, at least from the fault tolerance perspective, because zones do fail. Don't deploy. My personal advice: don't deploy your database in your application instance just in one availability zone, because it's just risky. Zones fail frequently. One of the reasons why every region comes with 3+ zones, because the cloud provider gives you a hint that zones do fail. That's why we have at least 3 zones that are usually separate data centers within your region. So, and when you deploy, if you even design if the first version of your application is designed to work within a single region, but across multiple availability zones, that's already geo-distributed application. Because if you designed it properly, then whenever you need to scale across multiple distant regions, across countries, etc., it's going to be easier for you because you already designed it for that way. But your first step, again, if you don't need to run across multiple regions, blah, 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 at least run across multiple availability zones. At least this is, if you want to take one takeaway from this session, take this one, please. Also, what if you want to learn more? Because I'm usually a bigger supporter of not only about the deep way of learning, but also broad learning. My usually advice is when people ask about the books, and these books are related to the geo-distributed apps. This one is designing data-intensive application. It talks about building different scalable and highly available and sort of a geo-distributed applications. It doesn't mention geo-distributed apps, but the concepts that we discussed today, some of them are covered in this book. Also, architecting for scale. This is for those of you who are already in the cloud, let it be private or public cloud. And this, if you still have any doubts about this high availability, etc., if you just don't fully trust me or my colleagues who presented before me, read this book as well. It's a very good blueprint. And database internals are for those who would like to dive a little bit deeper into the databases. If you want to learn more about YugabyteDB, we have a lot of resources. And if you have not attended our YugabyteDB University yet, please go to yugabytedb.com, pass our classes. They are free. You can get certified. Everything is for free and wonderful content. If you have any questions, if you want to discuss anything, if you want to run any idea by us, you can join our Slack, and you can just find me on Twitter, Denis Magda, my first and last name, single word, and let's stay connected. Okay, that's it. We have 20 minutes left. Feel free to ask any questions, whatever is not clear. Those questions might be about this session, so if you have any other questions that are related to Yugabyte, then also feel free to ask. All right. Okay. Let's wait for. Yep. Thanks, Jeff. Thanks. Hope it was useful. Okay. Then I'm waiting for a few extra minutes because sometimes it takes time for us to type a question and formulate it. I'll stay here. So feel free to ask, or as I said, we can connect offline. It's also possible. All right, my friends. Thanks. I don't see any questions, and I will just believe that you've got everything straight to the point, which means that take this, use it, and if anything else requires further explanation, you know where to find us, you know where to find me. Enjoy the rest of your day, night, or evening, depending on where you are. And I think that the summit, we still have the 15 minutes of the summit over. We have the last session, the closing session. Let's go to that one and see what are the last thoughts that the YugabyteDB team wants to share with us. Just hop into the last session. See you there. Bye-bye. Thanks for joining.